In this video, I will show you how to solve systems of equations involving conic sections. Now, you've learned about systems of equations before, where you're doing substitution and elimination, and what you are really finding are the intersection points between two functions, well, two equations. So, when you are given two equations that represent circles, the solution to that system will be the intersection points between those two circles. So we're looking for ordered pairs like 3, 5 or 2, -7. Let's solve this problem by substitution. Notice a little bit of a happy coincidence. We have this y plus 1 squared right here, and I see another y plus 1 squared right here. So if I were to get one of these by itself, I could substitute into the other equation. Let me show you what I mean. So if I wanted to isolate the lower y plus 1 squared, all I would need to do is subtract x plus 2 squared from both sides of the equation. Okay, so that would give me y plus 1 squared is equal to, should I turn this around? I guess I'll put it in the order of negative x plus 2 squared plus 25. I'm not sure it matters, the order. Anyway, I have y plus 1 squared. That means y plus 1 squared is equal to all of this. So what I can do now is substitute all of this into the other equation. So that's what I'm going to do. I'm going to make a new column to sort of keep things separated. But look at the other equation, which has x minus 5 squared over 1, and then minus, now they have y plus 1 squared. But I'm going to do a substitution. So since y plus 1 squared equals all of this, I can put all of this in the place of y plus 1 squared. So I can put negative x plus 2 squared plus 25 over 2. Okay, so this version of the equation only has x's in it. So I should be able to solve this for x if I'm very careful. Let's make like denominators so I can put these expressions together. So I can make both of these have denominator of 2 if I multiply the numerator and denominator by 2. So now these are like denominators. So I can put these together using the common denominator of 2. So here's what I have. I have 2 times x minus 5 squared. Minus a negative is addition. So this is going to be plus x plus 2 squared. Okay. Minus 25, so that's going to be minus 25. So notice it's like I'm distributing this negative sign throughout. So this had to become a positive, and this had to become a negative. Alright, because I'm subtracting the 25. I'm subtracting each of these things, so this 25 is going to become a negative 25. Sooner or later I need to get rid of the fraction, the 2 in the bottom, so I might as well do that now. So I'm going to just go ahead and multiply both sides of this equation by 2. That's going to cancel these 2's out. And also I need to start multiplying all this out to get rid of these parentheses. Whatever you do, don't try to distribute the 2. When you have something squared, you're going to have to do x minus 5 times x minus 5 first. Okay, and I've got x plus 2 times x plus 2 minus 25, and now it's all equal to 2. So this, if you multiply this all out, you're going to get x squared minus 5x, and minus 5x is negative 10x. I'm just combining like terms in my head. Plus 25. Okay, if I double distribute this, I'm going to get x squared plus 4x plus 4 minus 25 is equal to 2. Okay, distributing the 2, I've got 2x squared minus 20x plus 50 plus x squared plus 4x plus 4 minus 25 is equal to 2. So, combining like terms, 2x squared plus x squared, so that's going to be 3x squared, negative 20x plus 4x is going to be negative 16x. Now, I've got 50 minus 25 is 25, plus 24, plus 4 is 29. So I'm going to have plus 29 is equal to 2. So at this point I need 0 on one side, so I can either factor or use the quadratic formula. So then I will have 3x squared minus 16x plus 27 is equal to 0. Alright, it's time to try to factor this if we can. If it's unfactorable, there's always the quadratic formula. 3x squared can only be 3x times x. 27 is either going to be, 3 times 9 or 9 times 3, or technically it could be 1 times 27. I know none of those things are going to work out because there should be no common factor inside of the parentheses here. And whether there's a 3 here or a 9 here or even a 27, well, I guess, if I did 1 times 20. Anyway, this is unfactorable, is what I'm saying. So we're going to have to resort to the quadratic formula. So remember, the quadratic formula goes like this. X is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. However, this part of the quadratic formula under the radical is known as the discriminant. And you should always calculate the discriminant first, because depending on how that turns out, you might not have to do anything else. So let's focus on the discriminant. So b squared minus 4ac. Of course, this is a, this is b, and this is c. So when we talk about b squared minus 4ac, we're saying negative 16 squared minus 4 times 3 times 27. That turns out to be negative 68. If the discriminant is negative, that means you don't have any real solutions. You have a negative under a radical, that's imaginary. So we're just going to say none. Alright, there are no real solutions to this system. And actually took an extra minute to graph this on Desmos.com. Maybe you can take a look at this with me. Okay, I think you can see it over here. The circle and the hyperbola that we were just graphing, notice that they don't touch. There's nowhere that they intersect. So that's why this system has no solution. Number 2 is very similar. Again, we have a circle and a hyperbola, and we're trying to see where they might intersect. We have another happy coincidence. The y minus 4 squared appears in both equations. So we can build our solution around that. Let's get the lower y minus squared by itself, and then substitute whatever it's equal to into the other equation, like we did on problem number 1. Hopefully this time there will actually be a solution, because that would be nice to see. So if I were to subtract x minus 4 squared from both sides of the equation, I would have this. Y minus 4 squared is equal to 11 minus x minus 4 squared. Okay, so now going back to the other equation, I'm going to take all of this and substitute it in for y minus 4 squared. So I'm just going to write this equation down. I've got x plus 2 squared over 8 minus, and now here I've got 11 minus x minus 4 squared. Alright, I substitute for y minus 4 squared, all of this. So it's over 16 equals 1. So now I need to solve this equation for x. That's the only variable, so if there's a solution, we should be able to find it. In order to do this, I really need like denominators. So I notice that if I multiply this by 2, I'll have 16. So now I have like denominators. So I really can put all of this together. Just be careful when you combine these fractions. So I'm going to have the 16. So I'm taking these two numerators and putting them together. But it's what's really happening is I have this top numerator minus the second numerator. So this negative sign is going to have to be distributed throughout. So I'm going to end up with 2 times x plus 2 squared. Alright, now this minus sign is going to hit here and here. So I will have minus 11, but this minus has to change to a plus. Okay, that's the most common mistake. Students will just sort of join these together and they'll have minus 11 and then they'll just keep the minus. But it's sort of like if I have minus x plus y, you know, outside of parentheses, this would be minus x minus y. So you have to treat this numerator as though it were in parentheses and distribute this minus sign throughout. So make this a plus. That's a common mistake to watch out for. Anyway, we've got to keep going. So this is like having, well, you know what? I think I'll get rid of the 16 now by multiplying by 16. So if I multiply by 16 on both sides of the equation, where I also forgot to bring down the equals 1, oops. So I'm going to multiply by 16 on both sides of the equation. That way these 16s are going to cancel each other out. And so I need to get rid of these parentheses. So I have 2 times, and I'm going to go ahead and do x plus 2 times x plus 2 minus 11 plus x minus 4 times x minus 4, and this is now equal to 16. So if I multiply this together, double distribute, I will have x squared plus 4x plus 4 minus 11 plus, and if I double distribute here, I will have x squared minus 8x plus 16 is equal to 16. Now I need to distribute this 2, so I will have 2x squared plus 8x plus 8 minus 11, and then plus x squared minus 8x plus 16 is equal to 16. Okay, so now I need to combine my like terms. So I'm going to have, let's see, so I've got 2x squared plus x squared, so that's going to be 3x squared. I've got 8x minus 8x, so that's weird. Those are just going to cancel each other out, so those are gone. Okay, now I just have these guys. So I have 8 minus 11 plus 16. So that's just going to be 13. And I still have this equals 16. So x squared is the only variable, so I'm just going to go ahead and get this by itself. I'm going to subtract 13 from both sides. So that'll give me 3x squared is equal to 3. And so if I divide both sides by 3, I'm going to get x squared is equal to 1. Okay, so of course that means that x is equal to plus or minus 1. So these are my two solutions for x. So I need to remember this because I have to substitute this back in to the other equation to find y. Let me just keep this separate. So remember, x can be positive or negative 1. So let's say x is positive 1. Let's substitute that in and see what we get. Maybe I'll label my work. Okay, so first let x equal 1. Okay, now let's see what y turns out to be. So this would be y minus 4 squared is equal to 11 minus, and x is 1 now, so that's 1 minus 4 squared. So I've got y minus 4 squared is equal to 11 minus negative 3 squared. Okay, so that's 11 minus, negative 3 squared is positive 9. So y minus 4 squared is equal to 2. Okay, so now I would take the square root of both sides. So this is going to give me y minus 4 is equal to plus or minus the square root of 2. So that means adding 4 to both sides, I have y is equal to 4 plus or minus radical 2. Alright, so this is actually two separate solutions. Remember that we just let x equal 1, but we have two values of y that come out of this. So I'm going to begin to write my solutions over here in this area. So we let x be 1. So we had 1 comma, and then we have 4 plus radical 2. Alright, so that's one solution. And then we have 1 comma 4 minus radical 2. So that's a second solution. Alright, so but remember, x could equal positive 1 or negative 1. So let's go back and let x equal negative 1 and see if we come up with more solutions. Okay, so now I'm going to go back and I'm going to let x equal negative 1 and see what we get. So if x is equal to negative 1 instead, and I'm still using the same little equation right here. So I've got y minus 4 squared is equal to 11 minus, and now here's the negative 1, minus 4 squared. So I just wrote down the same little equation, but I put in negative 1 for x this time. Okay, let's see what we get. So we have y minus 4 squared is equal to 11 minus, and this would be negative 5 squared. Okay, so that's y minus 4 squared is equal to 11 minus, and this would be 25. Interesting. So I've got y minus 4 squared is equal to negative 14. And we can just stop right there. There's no way you're going to square something and get a negative number. Or put another way, if I take the next step and take the square root, you can't take the square root of a negative number. That's imaginary. So the two solutions that we already have found are the only two solutions. So that's it. This is the answer to problem number 2. Let's go ahead and take a peek at Desmos and see what was going on. So we had a hyperbola and we had a circle, and as you can see, we do have these two intersection points right here. 1 comma this, 1 comma that, and you can bet that this 5.414 is corresponding to 4 plus radical 2. And the 4 minus radical 2, you can bet that that's 2.586. Alright, so we just found these two intersection points. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.